Okay, good morning. And today we're going to look at some probability work, and we're going to use a great task from nRich called flipping discs. Now, we don't expect everybody to have colored discs at home, discs with one side one color and one side a different color. But you can do this task either just by shading in your book and drawing the discs. But it's quite nice. It is quite nice to have something to actually play with and manipulate at home. And so coins are very, very simple to use in this case. So I'm going to use discs. One side of a disc will be blue. The other side of a disc, whoops, Daisy, I've just dropped it, will be red. But if you're at home and you want to get a manipulative or something to use, a coin is a great idea. I'm in Hong Kong, so I've got a bunch of $2 coins here. It doesn't matter what coins you've got, but try and get them the same coin. And on one side of a coin is different, nearly always different to the other side of a coin. The coins I'm using here, $2 coins, we've got the Hong Kong Bohemia flower on one side, and I've got the number 2, it's a $2 coin, on the other side. So I can use these $2 coins as one side or the other side. But on my screen here, I'm going to use colored discs, and I'm going to flip a disc. So I've got a disc or a coin. Flip it or just toss the coin. It's going to fall, and it will either fall blue side up or red side up. It'll fall blue side up or red side up. My coin, if I'm using coins here, will either flip, and my coin here will either be a flower, a Bohemia flower, or the number 2. If you're in a different country, you can just use different countries' coins. You can use heads or tails in some countries. But here we've got flipping discs, and you kind of get the idea. We're going to flip we're going to flip 2 of these discs to start with. Getting carried away. We're going to flip 2 of these discs to start with. So if I'm using coins, I just take 2 of my coins, and we're going to look at flipping these. So I can just flip these discs and see how they fall. And the first game is simply that you flip 2 discs, or you flip 2 coins, and if they land the same color up, you win the game. And if they land with one color different to the other color, you lose the game. So you flip 2. If they land the same color up, you win. If they land different colors up, you lose. If it's coins, of course, I can flip these 2 coins. If they both land with the number 2 facing up, I would win. If they both land with the Bohemia flower facing up, both of them, I would win as well. But if one lands with the Bohemia flower up and one lands with the number 2 up, I would lose. Okay, so the question straight off is what chance have you got of winning? How often will you win? What's your probability of winning? All different ways of saying a similar thing. What's your chance of winning? Your probability of winning? How many times do you expect to win if you play this game, let's say 10 times or 20 times? So see if you can try and answer that question. Pause the video, see if you can answer that question. You may need to go and run and get some coins. So pause the video and see if you can think about how often you would win. Okay, so you've probably had a good go at that. So you might have a good answer. You might have a kind of answer something like, I'd win half the time, or I'd win 50% of the time, or if I played 10 games, I would expect to win 5 times. So all of these different ways of saying a similar thing, and we're going to try and formalize that now a little bit. I'm going to also explain why that is the case. Some of you may already know a bit about probability. Others may not at all. So we're going to really think about how we can show this working and how we can explain what's going on. So one way I could do it is to take these discs. Again, I'm using discs, not coins. And I could try and explain all the different outcomes. That's a key word. So I'm going to write that word down. All the different outcomes. Again, mathematics is such a language-rich subject. I'm going to try and list all of the outcomes. What are the outcomes? I'm going to write it a bit neater than that. I think it deserves to be written a bit neater than that. What are all the outcomes? So let's write the question. What are the possible outcomes of this event? 2 key words there. And if you want to have a pause there and think about what these 2 words mean, these outcomes of these events. Really, 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 really important words there. Outcomes, outcome, and event. Two keywords in probability work. Okay, and you might want to try and think, well, okay, what are the possible outcomes of this event? So you might want to pause now and see if you can write down and record the outcomes of this event, all the different possible outcomes. See if you can do that. Okay, probably had a good go at that. So outcomes, events. The event is flipping the coins, 2 coins or 2 discs, flipping these discs. That's called the event, actually doing it. The actual outcome is what happens at the end of the event. So my event is flipping these 2 discs, and one outcome I can think of is that they might land with both, in my case, both heads up like that. Sorry, both blue faces up. If you're using coins with heads on, it might be that they're both heads up. If I'm using Bohemia flowers and 2s, it would be both 2s up maybe. Okay? So if that's helped enough, pause the video again. See if you can write down some other or draw out some other outcomes of this event. Okay, we'll carry on. You may have thought about a different outcome of this event. You may have thought, well, maybe they could both land red face up. That could be another event. So I've got one outcome of the event would be both blue up. The other outcome of the event would be both red up. Okay? What's a different outcome? Well, a different outcome could be my first disc is blue and my second disc is red. That's a third different outcome. And my fourth outcome, I could have a fourth outcome. My first disc could be red and my second disc could be blue. And I think there are in total 4 outcomes of this event. Now, sometimes this confuses some people, the blue, red, and red, blue. They think, well, is that not the same? Well, if you hold your 2 coins, or your 2 discs, if you've got a disc at home, if you hold these 2 coins and put one of them, in this case, I've got a 2 and one a Bohemia flower, or a blue and a red up, and then you change that to this one around that way and this one around that way, that's a different physical outcome to this event. That is physically a different outcome. This coin has changed its outcome and this coin has changed its outcome. So that's a different physical outcome. Although it's still one red, one blue, it's a different one that's red and a different one that's blue, or a different one that's a 2 and a different one that's a Bohemia flower. So that's a different physical outcome to this event. So in total, there are 4 different outcomes to this event. So I'm just going to write that down. There are 4 possible outcomes for this event. 2 of the 4 outcomes are what we were considering as wins. If you look, 2 blues, 2 reds. I said if the colours are the same, or the coins show the same face, that's a win. That's considered a win. So we've got a situation where 2 of our 4 outcomes are considered wins. So what's your probability of winning? You will win. So you win 2 out of 4 times. You win 2 out of 4 times. Maybe I should write that as a sentence, and then we'll talk about the mathematics of it afterwards. You will win 2 out of 4 times. Now, you're not absolutely guaranteed to win 2 out of 4 times. There's an element of randomness. There's an element of randomness in this game. This is actually a random event. When I flip my coins, if I'm at home here, if I flip my coins, I can't guarantee that 2 out of every 4 times I do it, I will win the game, that 2 of my discs will face the same or face up the same color. So that's another word in mathematics that we might want to think about. There's some randomness. You might want to pause the video and think, well, what does randomness mean? What does random mean? Random. And random, of course, I can't control the outcomes of these events. I can't control it in any way. So when we're giving answers to these types of questions, this is what we would expect to happen. This is what we'd expect to happen. So I'm just going to write some notes on that. So some great words again for you there. So I'll write a note that these are expected outcomes, what we might expect to happen. Okay. The event has random outcomes. So we cannot guarantee these outcomes. And again, if you're not sure about any of those words there, not exactly sure how they're worded, so these are expected outcomes. The event has random outcomes, so we cannot guarantee these outcomes. These are expected to happen, but there's a random event and we cannot guarantee these. So we'd expect you to roughly win about half of the time. So if you played the game 10 times, you'd expect to win about 5. You wouldn't be guaranteed to win 5. There's a random element of chance. There's another word for you, a random element of chance. Let's recap some of these words, because powerful words in mathematics, you have to know the language of mathematics to be able to do mathematics. So we've got outcomes, we've got event, we've got expected, we've got random, we've got guarantee, and then another word, chance, that I've used there. In any random event, you've got a chance of something happening or not. And so let me just write that word down as well. You may have heard this word before, chance. So what mathematics can we kind of attach to this? Well, the mathematics we can attach has if we expect to win 2 out of 4 times. Here we go. We're going to write now some mathematics to help us. We expect to win 2 out of 4 times. We can write something like this. Big capital P for probability. The probability of winning is equal to 2. We can write it as a fraction, 2 out of 4 or a half. In a case like this, I'd probably use a fraction. Some of you may know that fractions can be the same as, or have the same values as decimals, so I could put 0.5. Some people might think percentages are the way to go, a fraction out of 100. So you could write 50 out of 100 or 50%. But in this case, I might just write a fraction, a half. And if you want to be really, really, really pro with your maths, you could write something like this. Big capital P, and the whole world of maths knows that that means probability when you put a bracket like that, big capital P in a bracket, and an event outcome inside. We know what that means in maths. We know that means a probability of a win equals a half. And so you can save yourself a bit of time. Rather than writing probability of winning, you can write big capital P, open bracket, win. So there's an example there of knowing the language of mathematics actually saving you time. Okay, so you can save yourself a bit of time there if you really understand the notation and the language of mathematics. So you may have got the answer, half, 50%, very, very early on, but could you write all the outcomes out? Could you use the correct language to explain exactly why that is the case? Maybe, and very well done if you did, but that is the way to go. And so now we're going to play a new game. And we skip down here, and now in mathematics, you can always go to the next step, always, but in quite a simple way in this case, because now, of course, all I do is I pick up another coin. There's another coin. So now I've got how many coins? 1, 2, 3 coins. or 3 discs in this case. Each of them has a Bohemia flower on one face and the number 2 on the other face. And then what I'm going to do now is just play the same game. I'm going to flip these coins, or flip the discs I've got here, and I'm going to win if every single face is the same. So I would only win on my coins if everything said 2. Every upper face said 2, or every face is a flower. They'd be wins. And then you got to think, well, what's now my probability of winning in this case? My probability or chance of winning in this new game with 3 discs, or 3 coins if you've got coins at home. Okay, so pause the video, see if you can do exactly as above, where you list every single outcome, where you draw every single outcome, and see if you can work out my probability of winning. Good luck. Oh, tip, try and use a system. Try and be systematic in what you do when you're trying to list these outcomes. See if you can use a system to keep track of your mathematics and your outcomes. Answers in just a moment. Okay, so here we go. So you've probably got your discs and you thought, right, okay, let's go for wins. That's not what I wanted to do. Let's go for wins. Now, for wins, let's go for the wins. Let's go for, right, 3 blues. That's clearly a win. Either 3 heads or 3 Bohemia flowers or 3 number 2s, whichever way you're doing it at home. Okay, 3 blues, that's a win, isn't it? There we go. And of course, 3 reds, that would be a win as well. The opposite side of the coin, 3 wins. There we go. Lovely, so we've got 2 wins. Now, is there any other ways of winning? I don't think so. I think that's probably the only 2 ways of winning there. But of course, to find the chance or probability of winning, I'm going to need to work out all the ways, all the other outcomes of this event, so that I can then do my mathematics and work out my chance or probability of winning. So, system. What system could I use? Okay, let's just do a different outcome to start with. Let's go for a losing outcome. This 2 blues and a red would be a losing outcome. Now, I've got to think of a system now, otherwise I might forget some. So that's 2 blues and a red. I could stick with that idea, couldn't I? I could stick with 2 blues and a red and list the outcomes of 2 blues and a red. Now, can you see that this, if I stick with this system of 2 blues and a red and covering all of those, I can see that system has given me a lovely pattern, and that's great in maths. When you use a system really well, you can see that I've got a nice systematic approach to my maths, and I can see that I've got my 2 wins here, but these are all losses. But can you see that system I've used to make sure I don't lose any of them? 2 blues and a red can be done in that way, or this way, or this way. The first disc could be blue, second blue, third red, or the first disc could be blue, the second could be red, and the third could be blue, or this one, first red, second blue, second, third blue. And I don't think I can do 2 blues and a red in any other way. So that is 3 different ways to have 2 blues and a red. And later on in your maths career, as you move up the school or move up in high school, you'll do some more mathematics on that type of thing. How many different ways can you have 2 discs blue and 1 disc red? It's another kind of level of mathematics, which is really cool. So if you want to try now and pause and think, well, there must be some other outcomes. Let's see if I can follow this system and do the other outcomes. Pause now. But let's try and do the others. So I'm just going to move these red discs out of the way because I want to use this space here without scrolling down and losing some of my outcomes. So you may have thought about this and thought, well, the other way to lose would be to have 2 reds and a blue. So you can have 2 reds and a blue. Okay, let's move those over so you can see them. 2 reds and a blue. I can make my little, I never knew I could do that. That's cool, isn't it? 2 reds and a blue. Like, well, there must be more than one way of 2 reds and a blue if there's more than one way of two blues and a red, you might be thinking. So, and you'd be absolutely right. But if we follow this same kind of systematic approach to finding the outcomes of this event, we can do this. There we go. That is very cool. There we go. There's three ways of having two reds and a blue. If you're using coins, it's two heads and a tail or two tails and a head. There we go. Now, are there any other outcomes here? Are there any other possible outcomes? I've got three coins or three discs. They've got to be blue or red. I don't think so, right? Because that's it. It can't be one red, one blue, and one something else. There's only two sides to a disc or two sides to a coin. So I think that is all our outcomes. And it's a great systematic way of doing it. And now all we need to do, of course, is work out the probability of winning. So let's shift all these over here and leave a bit of space now because we've got some unused discs here. And let's try and write our probability of winning here now. Now we've learnt a fantastic new way of doing this because we now know that these are my wins. So these are my wins, two of them. These are my losses with two blues and a red, and these are my losses with two reds and a blue. Now, how many of those are there? There's 1, 2, 3, 4, 5, 6. There's my wins is 1, 2 ways. So there's 2 ways to win, and these are my losses, and there's kind of 6 ways to lose. In total, there are 8 different outcomes to this event. 2 wins, 6 losses. Add them all up, there's 8. So I think there's wins. The probability of winning, I'll put the word win in now. The probability of winning is 2 out of 8, which we can write as a fraction in its simplest form. 2 out of 8. 1, 2, 3, 4, 5, 6, 7, 8. 2 out of 8 are wins, which is a quarter. A quarter. Or 25%, I suppose you could write, or 0.25. But in this case, because it's numerator and denominator, the denominator of the number of outcomes, the numerator is the number of ways you can win, or the number of outcomes in which you win. 2 out of 8, and the quarter looks to be the best way. So if you got that answer with no help at all, that's absolutely fabulous. What's the next step? You've probably guessed it now, because if you've been doing some of this work for a while, you think, well, hang on a minute, in mathematics, we can make things more complicated and more in depth and more problem solved just in quite a simple step sometimes. So we've done 2 coins, we've done 3 coins. Well, I wonder what the chance of you winning, or the probability of you winning, would be with 4 coins, when the win would only be all coins face up the same color in this case, or heads, all tails. So 4 coins. The probability of winning with 3 coins, let's have a look at it. The probability of winning with 2 coins, the probability of a win was a half. With 3 coins, the probability of a win was 1/4. So I'm just wondering, do you think you could predict, another amazing maths word, can you predict the probability of a win with 4 coins? Do you think you can predict a win with 4 coins? Could you prove and show me and justify with a systematic approach, a diagram showing all my outcomes, and predict that win ratio, that win probability with 4 coins? Have you got a prediction that you could then check with full working? Is that possible? And again, you've made that extra step. Can you predict with 5 coins? Now, at this point, diagrams might get a little bit tricky and hard to draw. So let's have a little look at how I could do it differently. Or what I could do is look at my outcomes in a different way. So for 4 coins, let's have a think about how I could, in mathematics, simplify it a bit. I could try and write a bit more clearly than that. I would expect my students to write a bit more clearly, so apologies. What I could do is I could do this, couldn't I? I could start listing like this. Well, a win would be blue, 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 capital letters. Outcomes, we usually use capital letters. A win, we don't have a red. Let's try and get a red up. There's a red. Red, 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 red would also be a win. So there's two ways of winning. Now let's start thinking about all those ways of losing. Let's go for, if you remember, systematic approach. Now I've lost my blue. Oh, I know what I need to do. I need to go here and change one of these colors. I don't really use yellow very much. So let's change that one to a blue. Which blue's the nicest? That one. Okay, so there we go. Lovely. So I could lose with 3 blues and 1 red. And I could use my systematic approach, couldn't I? There's 3 blues. That's a bit wrong. My systematic approach and have 3 blues and a red that way. Oops. 3 blues and a red that way. And I could just use capital letters like that and count up all my different outcomes. Now be careful there. It's a little bit more complicated than 3 coins. A little bit more complicated because of course you can have a bit of a tip for you. Excuse me. You can have 3 blues and 1 red. That would be a loss. You could have 3 reds and 1 blue. They'd all be losses. You can also have 2 blues and 2 reds, and all of those would also be losses. So a little bit more complicated than you think, but see if you can work out that probability of winning with 4 coins. Then see if you can predict for 5, because you could probably spot a pattern then and see whether you can work out the probability of winning with 5 coins. Good luck. Very well done for sticking with this. And that is your introduction to probability, outcomes, events, working systematically in mathematics to make sure you get the right answers. Thank you. Bye-bye.